In a high-stakes Cold War confrontation, a surprise nuclear strike could render the defense forces of West Germany entirely defenseless within 15 minutes. This terrifying reality forced engineers to build the EWR-VJ-101C, a radical West German fighter designed to defy physics and launch directly from hidden forest clearings. On July 29, 1964, this experimental jet shattered expectations by pushing past Mach 1.04, making it the very first supersonic vertical takeoff aircraft in human history. Yet, just 47 days after this historic breakthrough, the flagship prototype crashed into flames on a runway in Manching, setting off a chain reaction that ultimately destroyed the program. How did a revolutionary interceptor that outperformed early NATO concepts by 50 years vanish into total obscurity? By 1959, military strategists calculated that conventional airfields across West Germany were hopelessly exposed to Soviet short-range ballistic missiles. On paper, their only tactical salvation would be a point defense fighter capable of vertical takeoff and rapid ascent to 70,000 feet. The engineering answer was the EWR-VJ-101C, a 6-ton aircraft featuring a unique propulsion layout. Power came from 6 Rolls-Royce RB-145 turbojet engines, generating 2,750 pounds of thrust each. 2 engines sat vertically in the fuselage for lift, while 4 were mounted in rotating wingtip nacelles, governed by an early 3-axis fly-by-wire stability system. The aircraft successfully transitioned from vertical hover to horizontal flight on September 20, 1963. Leading global defense analysts argue that while this design represented an extraordinary leap in aerospace engineering, its extreme technical complexity created insurmountable vulnerabilities. Before we go on, do you think NATO made the right call by canceling this supersonic vertical jet? And tell me where you are watching from. Subscribe to the channel to never miss our deep dives into military history. To understand the urgency behind this engineering marvel, one must examine the operational doctrine of the early Cold War. With forward air bases targeted for immediate saturation, conventional combat aircraft like the F-104G Starfighter risked total destruction on the tarmac. German strategists demanded an interceptor requiring 0 runway distance, designed to disperse into rural areas and scramble within seconds to engage incoming high-altitude bombers. In 1959, the West German Ministry of Defense established the Entwicklungsring-Sud Consortium, uniting Messerschmitt, Heinkel, and Balkow. Their objective was to construct a Mach 2-capable interceptor with true vertical operational independence. The resulting EWR-VJ-101C integrated 2 vertical lift engines directly behind the cockpit, complemented by 4 primary engines housed in swiveling wingtip pods. These wingtip nacelles could rotate 90 degrees, facilitating a fluid transition from hover to forward flight. Managing 6 jet engines simultaneously pushed 1960s computing capabilities to their absolute limit. Engine thrust regulation replaced traditional control surfaces during vertical maneuvers, overseen by a pioneer fly-by-wire network. The development advanced rapidly. On April 10, 1963, the X-1 prototype completed its inaugural free hover in Manching. By September 20th of that same year, full transition to horizontal flight was achieved, proving to international defense analysts that a supersonic tiltjet configuration was technically viable. Despite achieving supersonic capability, the EWR-VJ-101C program harbored severe technical vulnerabilities that ultimately triggered its downfall. The first fatal blow struck on September 14, 1964. During a routine horizontal takeoff, the X-1 prototype pitched wildly out of control and crashed after reaching an altitude of just 10 feet. Investigations revealed that a technician had installed a roll-channel gyro sensor with reversed polarity. The automated fly-by-wire system, misinterpreting the orientation of the aircraft, actively drove the jet into the ground rather than stabilizing it. Beyond control failures, fundamental physical obstacles severely plagued the second prototype, the X-2, which flew on June 12, 1965, equipped with afterburning engines. During vertical operations, the 6 engines produced scorching exhaust temperatures exceeding 1,000 degrees Celsius. This superheated air bounced off the pavement and re-entered the engine intakes, a phenomenon known as hot gas ingestion. Leading defense analysts noted that this starves turbojets of oxygen, causing sudden thrust loss during critical hover phases. Furthermore, the extreme thermal blast melted asphalt and eroded concrete runways within seconds, sending lethal debris into the air intakes. The final nail in the coffin came from shifting strategic priorities within NATO. By 1967, NATO abandoned its doctrine of massive nuclear retaliation in favor of flexible response. Military strategists no longer required a specialized, short-range point defense interceptor that consumed half its fuel payload just to take off vertically. Instead, NATO demanded versatile multi-role strike aircraft with long endurance and heavy ordnance capacity, such as the F-4 Phantom II and the emerging Tornado project. Maintaining 6 complex jet engines on a single lightweight fighter created a logistical nightmare that proved financially unsustainable. Facing mounting budget deficits and changing tactical requirements, the West German Ministry of Defense officially canceled the EWR-VJ-101C project in 1968, putting a permanent end to this ambitious vertical jet. While the official cancellation in 1968 relegated the EWR-VJ-101C to museum halls, its technological footprint left an indelible mark on modern aerospace engineering. Historians often highlight a fascinating parallel between West Germany and the United States during this era. The swiveling wingtip nacelle concept of the EWR-VJ-101C mirrored the earlier American Bell D-188A XF-109 project, leading defense analysts to argue that both nations were racing toward a shared vision of supersonic vertical flight. The ultimate legacy of the EWR-VJ-101C lies in the vital engineering lessons forged from its failure. By attempting to balance 6 independent turbojet engines, West German engineers exposed the insurmountable limits of 1960s mechanical control and thermal management. 4 decades later, when Lockheed Martin developed the F-35B Lightning II, designers solved the hot gas ingestion problem by abandoning multiple lift jets entirely. Instead, the F-35B utilizes a single main engine paired with a shaft-driven lift fan, a direct architectural evolution informed by the hard lessons of the EWR-VJ-101C. The story of the EWR-VJ-101C demonstrates a profound truth in military aviation history. Engineering genius alone cannot save an aircraft if materials science is not yet ready, or if geopolitical doctrines shift beneath its wings. West Germany built a machine that truly defied physics, but it was simply born 50 years too early for its operational environment. Do you believe NATO made a tragic mistake by abandoning supersonic tiltjet technology? Or was the EWR VJ-101C an inevitable dead end? Share your thoughts in the comments below, and do not forget to like and subscribe for more deep dives into military aviation history.